Hello there, welcome to Pre-Cal Lecture 2.5, where we're going to talk about the quadratic formula. So we want to use the quadratic formula when a quadratic equation can't be factored or solved easily by completing the square. So, there's definitely easier ways to go about solving a quadratic equation than using the quadratic formula, but sometimes it's just what you have to use. So we need the form a times x squared plus b times x plus c equals 0. So if it's not in that form, let's say c is on the right side, you have to move it to the left. All right? And so the quadratic formula that you need to memorize, and you probably have, certainly by Algebra 2, is negative b plus or minus the square root of b squared minus 4ac. So we're using these coefficients out in front of the x squared and the x, and then the constant all over 2a. So that you do have to have memorized for the test. Okay, let's do an example. Let's say we want to solve for x, and we have 3x squared minus 5x plus 3. All right, you try to factor it, can't do it. Completing the square is kind of a pain because you have, you divide everything by 3, you end up with a fraction on the middle term, so it's just not worth the trouble. But a is 3, b is negative 5, and c also 3. So going through the formula, we have negative b. So I'm going to write all that out here. A is 3, b is negative 5, c is 3. All right, so negative b would be negative 5, which is 5. So we'd have 5 plus or minus the square root of b squared. So negative 5, we need to put that in parentheses, squared, minus 4. A is 3, c is 3. All that's under the radical over 2 times a, so 2 times 3. So that's going to be 5 plus or minus the square root. 4 times 3 is 12, times 3 is 36. So negative 5 squared would be 25 minus 36 over 6. So that's going to be 5 plus or minus the square root of negative 11 over 6. So goodness, the first example I gave you has a complex answer. So that's going to be 5 plus or minus, so this is the square root of 11i. Remember, I is negative 1, so it's square root of 11. All right, so over 6. All right, so that's the answer. There are no real answers. To this problem. So rare that we pull out as our first example, a kind of a crazy problem, but that's what we did this time. Okay, so let's keep going. So we're still in 2.5.1. I got a tickle in my throat, so I'm going to have to take a minute maybe to take a drink. Let's go ahead and write the quadratic equation again. So we've got negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, our next example, and we're just solving. And we've got the square root of 2 times x squared plus 3 times x plus the square root of 2 is equal to 0. So it's already in the appropriate form, right? Ax squared plus bx plus c equals 0. If it's not in the appropriate form, you have to get it there. Okay, so a is the square root of 2, b is 3, c is the square root of 2. So we have negative b, so that's negative 3, plus or minus the square root of b squared, so 3 squared, minus 4 times the square root of 2, times the square root of 2, that's a times c, all over 2a, so 2 times the square root of 2. So that's negative 3 plus or minus the square root. Now root 2 times root 2 is 2. 2 times 4 is 8. So that'd be 9 minus 8 over 2 times the square root of 2. So that's going to be negative 3 plus or minus the square root of 1 over 2 times the square root of 2. I'm doing this for illustrative purposes. You know the square root of 1 is 1. So that's negative 3 plus or minus 1 over 2 times the square root of 2. So we've got two answers. Negative 3 plus 1 is negative 2 over 2 times the square root of 2. And then negative 3 minus 1 would be negative 4 over 2 times the square root of 2. Now we can simplify these a little bit. That would leave negative 2, so those would cancel and you'd have negative 1 over the square root of 2. And then negative 4, that would be 2 and 1. So you would have negative 2 over root 2. All right, now I am totally fine with those two answers, but let's say you were asked to put them in proper math format by getting rid of the radical. We could rationalize, and I'll remind you how to do that. So for this first one, we'd multiply it times root 2 over root 2, so that's a negative root 2 over 2. Okay, so that would be a rationalized form of the answer, and then negative 2 over root 2, the second answer, times root 2 over root 2 is negative 2 root 2 over 2. And then that's going to cancel out. The 2's will cancel, and you would have negative root 2 left. Some math teachers are going to want this format, or if you took a multiple choice test, that would be the correct answers in A, B, C, or D. You know, that would be your options. So you have to know how to do it. But on my test, unless I say you've got to rationalize the answer, you don't have to. Okay? I do want you to, however, do this, simplify it down like I did here and here. Okay? But you don't have to get rid of the radical in the denominator unless I ask you to do that. All right. Erase part of my formula there. Okay, this is a real short lecture, so I've got a section 2.5.2. I'm going to leave the quadratic formula up there. So 2.5.2 is quadratics finding real number restrictions. All right, finding real number restrictions. So remember from a previous lecture in chapter 1, the domain is all real numbers except where the denominator is equal to 0. So our example would be find the domain and we have 3 minus 2x over 3x squared minus 19x minus 14. Okay, so I don't really care about the numerator. I only care where the denominator is equal to 0. So let's set the denominator 3x squared minus 19x minus 14 equal to 0. Now, you know, you would immediately probably look at that and say, that's going to be hard to factor. Let's go ahead and stick it in the quadratic formula. That's fine. But let's go ahead and try to factor it, see if we can. Because this first number is 3x and x, a prime number. 14 is going to be 14 and 1, or it's going to be 7 times 2. And I know that if I have a 7 over here, I've got 21. And if I've got a 2 here in the middle, 2, I can do 21 and 2 and get a 19 out of that. So how about plus minus? That'd be 3x squared plus 2x minus 21. That'd give me minus 19 and then minus 14. So we'd have 3x plus 2 equals 0 and x minus 7 equals 0, setting each set of parentheses equal to 0. So 3x equals negative 2. X is negative 2 thirds. And here x is equal to 7. So the answer is that x cannot equal negative 2 thirds or 7. All right, x can be all other numbers except those two. Now, if you were to put this in the quadratic formula, 3 would be A, negative 19 would be B, negative 14 would be C, and you would have positive 19 plus or minus the square root of negative 19 squared minus 4 times 3 times negative 14 over 2 times 3. And if you were to go through that, you would come up with negative 2 thirds and 7. But if you want to at least give a little try to factoring it so you don't have to go through all that. All right, so but anyway, you feel free to solve the problem, on your own if you want, and see if you end up coming up with negative 2 thirds and 7 using quadratic formula. You probably employ your calculator here. All right, so last little note would be, if you can't factor, then use the quadratic formula. All right, so and you may end up looking at that and say, I don't even want to bother to try to factor that. But the quadratic formula is complicated, and you can end up making mistakes just by accident. So I do think it's always worth trying to factor if you can. So the homework is worksheet 2.5a. There is no 2.5b. And you can see, for example, with this first one, you're going to have to FOIL that w minus 5 squared out and bring that 2w over to the left, combine like terms, in order to get the A, B, and C format. All right, so you have to solve using quadratic formula for all of these. So you're going to have to do that. And then for number 4, also you're going to have to pull these terms over to the left. All right, and then find the domain is like that our last example problem. You're only really worried about the denominator there. All right, so good luck on the homework, and I will talk to you on the next one.